All right, so I'm here today to talk to you all about CitrineOS, which is an open source project to create a charging station management system using OCPP 2.0.1. So I'm here at PlugFest with my team from S44. And if you have any questions about the project or about us after I'm done here, you can come to any of these people and ask us. So a little bit of background about me. I'm currently the director of the open source program at S44 for CitrineOS. And I have been working at S44 for the past 3 years, creating custom CPO software for charging networks in North America. So a little bit about who S44 is. Very quickly, we are a custom we can create custom software. We've been in the electrification space for more than a decade, and we have a focus on creating custom software for charge point operators and charging networks. And recently, we undertook a project to transfer one of the largest charging networks in North America from a proprietary software as a service solution to a custom CPO backend. We've worked with a lot of different EMSPs and a lot of the different OEM automotive companies in the space. We are, as was mentioned, a contributor to the EV Roaming Foundation for the OCPI protocol. And in October of 2023, we launched the open source project CitrineOS. So before I get into the technical specifics of Citrine, which, as I mentioned, is a OCPP 2.0.1-based charging station management system, I'm going to talk about why we decided to launch the project. So there's a lot of ambitious goals right now in electrification. The speed at which we're electrifying is only getting faster and faster. And in the US, there's a target to have 50% of all new cars be emission-free by 2030. And recently, there was an infrastructure plan that was passed that has earmarked $5 billion for the expansion of the US's EV charging infrastructure. And in conjunction with that money, a series of standards were set called the NEVI standards, which will be requiring all these chargers to be OCPP 2.0.1 compliant, and it will also require them to be interoperable so that they can swap between charging networks. And also, since we are in Germany, the German government also expects the amount of electric vehicles on the road to go up by at least 10 by 2030. So alongside these ambitious goals, we have to actually back it up with a solid user experience. And right now, that is not very consistent. And I think that one of the roots of the problem is there's too many cooks in the kitchen. There's the people who make the cars. There's the people who make the charging station hardware, the charging station software, what controls it in the cloud, and then the various apps that we use on mobile phones and dashboards to actually charge our vehicles. And one example of a solid, consistent user experience has been Tesla, but they're cheating. They control all of that themselves, which is not where the future of the industry is going to be. As I mentioned on the previous slide, interoperability of chargers is becoming a concern for governments. And it is going to be a requirement in building infrastructure across nations that these charging stations be interoperable across different networks. So the specific layer that allows chargers to be controlled like that would be OCPP mediated. And right now, 1.6 is the version of the protocol that we see in industry. But this has come with some gaps. There's certain functionalities, like being able to push down user interface components or pricing information, or do plug-in charge, or be able to surface issues about the hardware before they actually occur that are not very easy to do in 1.6. And this has led to a lot of customization. Most chargers out in the field today, they use 1.6 for a part of what they do, but a large part of what they do to actually operate the chargers is a custom extension to provide all of those things. And this makes it so that each implementation of charging station management software is siloed and proprietary, and you can't keep your feature set when you move between these systems. Now, OCPP 201 solves a lot of these problems. It provides you a way to do all of those things. You can push pricing and its user interface. You can do plug and charge. And you have a device model which provides very thorough and fine-grained control of the chargers and allows you to see everything that's happening on the charger and catch problems before they occur and take action. However, there hasn't been a whole lot of adoption of 201 quite yet. And one of the reasons of this is that there are a lot of big differences between 1.6 and 201, and it has been very difficult to make that transition. So there's been a lot said already about how open source is the answer. But I'm going to hit 3 quick points that I think are very relevant to why we created this project. One of them is that when you have an open source project, everyone is free to take it and use it and test it. And when you have that community around your open source project, you get a level of testing that you could not possibly acquire on your own. You have a wide diversity of use cases that people will bring your project to, and they will test things that you never thought to test, and it'll make your solution very robust. Additionally, when you've done it right, people will take your solution and they will build on top of it. And although some of that may be proprietary, they will also give back to the community, meaning that the project will expand. And CitrineOS today is an OCPP-based charging station management system, but if it sees a wide community adoption, it can expand into many other areas as the community grows. And finally, it's very useful for protocols like OCPP to have a common implementation that's free and accessible and transparent that people can use and reference. Everest was very useful when creating Citrine because I was able to spin up an Everest simulator on my computer and use that to test against during development. And similar to how that was able to help me develop Citrine, my hope is that Citrine can then help others develop either firmware or they can develop their own charging station management systems using Citrine's behavior as a starting point. So rehashing again, Citrine is an open source charging station management system using OCPP 201, and now I will get into some of the technical details of the project. It is written in TypeScript using Node.js. This was decided because JavaScript is consistently the most widely used language, and it was important to me that the project be very accessible and that everyone understand how to use it and add to it. It is API-based with a modular architecture, and I'm going to go into more detail about what that means. But the reason we did that is that it would be easily extensible and possible to fit into existing charging network tech stacks. It currently passes the OCA testing tools core and advanced security tests, and we are pursuing official OCA certification. It is under a Apache 2.0 license, and it was covered already what some of that means, but the very short of it is that it means that you can fork it, you can add your own IP on top of it, and you own that IP. And it was also recently adopted as a Linux Foundation energy project, which, as mentioned, means that they help us with the building of the community for the project, and they manage the branding of the project as well. So this is the system architecture design for Citrine. You can see over here is the central system. This is what maintains the WebSocket connections to the chargers. And it takes these messages and it puts them onto a message broker. The message broker itself can be implemented using any number of technologies. Already in the code base, we have support for MQTT in the form of RabbitMQ, as well as Kafka and Google PubSub. Then these messages are consumed from the message broker by a series of modules that perform different aspects of the OCP protocol and also perform other things, value added on top of just OCPP. For example, there's a payment module that was created by Stackbox that is supported by CitrineOS. Stackbox is here as well. They're another company in the space, and they've developed this module that allows you to do payment processing using Stripe with Citrine. There's also a common memory cache and a relational database, a SQL instance, on top of which we've added a Directus instance. Directus is an open source UI and serves as sort of the operator or back office user interface for Citrine. So this is an image of Directus, and you can see here geolocation information has allowed you to see 2 charging stations. Using Directus, you can manipulate the data that's in Citrine, such as user authentication data. You can also view the transaction data. Directus also has some useful functionalities, such as being able to create low-code flows, which allow you to automate certain aspects of what you need to do with your charging stations. So if you are frequently, when you commission a charging station, you may want to set up a boot process and send some specific messages. And you can automate the creation of those messages from the information about your charger using Directus. It also allows you to customize a dashboard showing statistics about your network that may be important. So I mentioned modular and API-based. So the different modules of Citrine consume the messages off of the message broker, and they handle different specific functionalities split up such that it's easy for the network to scale. So for example, the most commonly sent messages in OCPP for any network will be your meter values and your transaction events and your status notifications. And those are all on the same module, transactions, and it doesn't process any other messages, so that it can easily be scaled up independently of the others, which cover messages that are less frequently used. And as I mentioned, you can create third-party modules in order to expand the feature set of Citrine. And those do not necessarily need to use the same technology base as Citrine itself. If you want to, for example, write a module in a different programming language, you can, so long as it provides the interface to take the messages off the message broker and put them back on. And it is API-based for ease of integration into existing backends. So many charging networks out there already have their own internal solutions that operate on 1.6. And you don't necessarily want to have to drop everything that you've already created. So the API of Citrine allows you to leverage it without needing to recreate everything in your charging network. The API has 2 parts to it. There's a message API that allows you to push the messages, OCPP messages, down to the chargers directly. And it has a data API that performs CRUD operations on the information used in Citrine, such as user authentication information and transaction data. So getting even deeper into the technical aspects of how Citrine functions. So in the OCPP 201 spec, there is a section, part 3, which provides JSON information on all of the different messages used in the protocol. We actually use that to automatically generate the classes in TypeScript. So if there are future updates to the protocol, we can use that to automatically create the code needed to run with those messages. In order to make it easy to create modules in TypeScript, we created a series of decorators that allow you to mark functions for specific messages that will be picked up off of the message broker, as well as to create endpoints for either the message or the data APIs. And Citrine does support Swagger and has, when you are running it, an open API documentation page that allows you to see all the different endpoints that Citrine supports. So here's an example of how you would commission a charger with Citrine. To start with, when you're setting up the configuration of Citrine, you can set up different WebSocket servers on different ports for the same instance of Citrine. This allows you to support different security profiles. You can support no security if needed for development or prototyping. It then supports security profiles 1, 2, and 3 from OCPP 201, which is basic auth header with HTTP. Then it's basic auth header with TLS, and then finally mutual TLS. Once you've set up your WebSocket server and you have the port that you can then start connecting your charger to, the boot process, you can set what status the central system will report to the charger when booting. You can choose pending, which then allows you to push configuration down to the charger and do things like send a get base report. This behavior can be configured so that it happens automatically when the charger first connects. It will receive the pending boot. It will then send, say, a get base report. It will load in all the information from the charger. And then you can push down specific configuration if you need to before finally sending a second boot that will be accepted after the charger has been configured. And then in order to start your first charge, in order to start your first charge, missing an S there, you will need to enter the customer authorization data, which you can do either via the data API or via the Directus UI. And then you can authorize the charge, and once electricity is flowing and the data is coming in from the charger, you can view all of that transaction data in Directus. So this is a short-term roadmap for CitrineOS development. Right now, as I mentioned, we support the core and advanced security use cases with the first major version release, which occurred last month. In the near future, we hope to support all the other certification profiles in OCPP 201. Right now, you can send all OCPP 201 messages through Citrine, but the business logic is not yet there for all of those use cases. As I mentioned, Citrine is a Linux Foundation Energy project, and we'll be having our first technical steering committee meeting on March 14th. And I hope to see some of you there. There's already a large number of contributors who have expressed interest. And we'll be hashing out the details of this roadmap then. So it may become compressed, it may become earlier, and most likely there will be additional features that people are interested in adding to this roadmap. And so before I go to Q&A, one quick mention about how S44 can be involved in helping you implement Citrine. You can, of course, just take Citrine and run if you want. But we are the authors and thus experts on the topic. And if there's additional features missing from it that you would like made custom, that's what we do at S44. And also, we provide the ability to host an instance of Citrine as a software as a service offering. And if you're interested in any of that, you can scan this, and it will give you our contact information for you to learn more. And that's it. Open to questions.
Thank you. Questions?
Just a quick question. Do you plan to support 1.6?
No, not right now. I think so. I mean, as I mentioned in the early part of this presentation, 1.6 is currently the most commonly used standard. However, I think the purpose of Citrine was to provide a way to bootstrap yourself towards 201. And we have had the beginnings of some conversations of using Citrine in networks that are mostly 1.6 right now. And the thing about that is those networks are already running. They already have the ability to run 1.6. What they don't have is the ability to run 201. So the idea would be that you could run Citrine alongside your current 1.6 solution and bootstrap yourself over to 201 using Citrine. So right now, we do not have any plans to support 1.6 within the project.
Are you aware of any chargers in the US that are for sale that already support 201? Like commercial ones?
Yes. So, for example, Lincoln Electric is releasing the first US-made DC fast chargers, and they are going to, from the get-go, be supporting OCPP 201. And many existing charging manufacturers right now are interested in releasing a 201 implementation. So I expect within like the next year or two, there's actually going to be a wide number of already major charging hardware producers that will be supporting 201.
Cool, thank you.
Thank you for this nice talk. You mentioned in the beginning a little bit the word scalability. This brought me to a little bit thinking, I mean, which numbers of chargers you expect to handle in your backend system? Like, and where is here, like, the bottleneck number? Like, it's actually just a number like 500,000 chargers, because we are now small, but it sounds like there can be also a million or 10 million, or where you see you here, or the system is designed like that, I understand?
Yes, thank you for the question. We are in the early days right now, and the hope is that we'll be able to have some data from the field of how Citrine performs at scale, and also some load testing, but that's not yet been done. But in the conversations we've been having with the people who are interested in using it, I've heard everything from people who want to use it for a small number, say like 50 chargers, all the way up to something very, very ambitious, like 1 million. And as to how possible that is, I'll have to get back to you on that. But I'm hoping very possible.
Any other questions? Yeah.
Oh, I've been told that the QR code is not working. Olga's seated right here, so instead of the QR code, you can go to her.
Great, thank you very much. Can you give us an insight into the US market about DC and AC charging requirements?
Requirements?
No, the market, what does it demand?
Demand. So there is currently a lot of demand for fast charging. I think more so than in Europe, because there's a lot more people driving very long distances in America. There's a lot more of a culture of driving in general. And so DC fast charging is a huge focus of the industry right now. That being said, there are L2 chargers in the US. There's some cities which have taken upon themselves to install like municipal L2 chargers. And I think that's primarily where we've been seeing L2 chargers at this moment in time. That and L2 chargers that you can purchase and install in your home. But as for commercial L2 charging, that's not really been much of a thing in the US market to date. There's very much a focus on fast charging.
Thank you.
Yeah, thanks for your presentation, really nice. I think it's a good initiative. I was wondering, things like that can be very company specific, you mentioned something about user management. You now have your own implementation for that. Is it also that you can maybe extend? It's easy to extend. So, for example, if you want to use social login, or you have your own B2C instance, or things like that, there's a very specific. Is it something you have considered, or how do you think about that? Yeah.
So for the data models in use by Citrine for stuff like, say, authorization, we're trying as much as possible to stick to the data that is carried in the OCPP messages themselves. So we surface everything that OCPP is capable of sending, and we use that same structure in the SQL database. I think that this should make it should facilitate things like extending it to specific use cases for user information. And Directus is a starting point. If you wanted to build your own UI on top of the SQL instance, that's also something that can be done. So I think as long as all of the information that the chargers are capable of communicating to you via OCPP is easily available, which it is, you should be able to extend it.